are going to discuss about support reactions of beams and types of loads, right. So, what is beam? So, beam is nothing but it may be defined horizontal structure member which carries a load which is perpendicular to the axis of the beam. So, this is the beam and the axis of the beam which is horizontal, and that horizontal structure member which carries a load perpendicular to the axis and transfer the loads from ceiling to the columns through the beams, right. And types of supports. So, types of supports: simply supported beam, simply supported and roller supported, hinged or pin joint support and fixed support. So, totally the types of supports divided into 4, right. Now, so these are the symbols, the supports represented by so and so symbols and the corresponding reaction forces. So, now the roller support which is represented in this form, and the reaction force for this roller support which is the vertical. Only one reaction force is having this roller support, and that force which is perpendicular to the base of the roller, right. So, this is the vertical force is the only reaction force for this roller support, and this vertical force which is perpendicular to the roller base. Suppose the roller support is in the general position or initial position or the vertical position, and the reaction force which is perpendicular to the base. If the roller support is 90° clockwise, then the vertical force which is perpendicular to the base of the roller, right. Now, pin joint or pinned support. So, pinned support, this is the representation symbol, and this support is having two reaction forces, one is horizontal, another one is vertical, right. And fixed support is not necessary now. Then last one is simply support. Simply support, this is the representation of simply support, and the simply support is having only one force which is a vertical force, right. So, remember these forces, reaction forces, right. This is very, very important. Now, let us discuss about types of beams. So, types of beams is divided into 4 categories. One is cantilever beam and simply supported beam, overhanging beam and continuous beam. So, let us discuss one by one. What is meant by cantilever beam? So, cantilever beam is nothing but one end is fixed, or the fixed at one end and another end is free. So, this type of beams are called as a cantilever beam. One end, the end A is fixed and end B is free, right. Now, simply supported beam, which means the supports are at the ends of the beam, right. Supports are at the ends of the beam. So, simple beams which is supported, by two ends. So, then it is called as simply supported beam, right. The third one is overhanging beam, which means, see here two supports are there, here beam is projected beyond the supports. So, this type of supports are called overhanging beams, right. So, next one is continuous beam, which means the beam which has more than two supports, right. So, this continuous beam is differ from these three pictures, because so the simply supported beam, so see at two ends only two supports are there at end A and end B, whereas for this overhanging beam only two supports A and B, whereas for continuous beam more than two supports. So, this is A, B, C, D, right. So, more than two supports are there, then this is called as a continuous beam, right. So, now let us discuss now types of loads. So, types of loads: concentrated or point load, distributed load, right? So concentrated or point load, which means the whole intensity of the load is assumed to be concentrated at a point, then it is called as point load or concentrated at a point. That's why this is called as concentrated load, right? Then distributed load. So distributed load, which means the intensity of the load is distributed uniformly along the length of the beam, then it is called as uniformly distributed load, right? The rate of distribution is even along the length of the beam. That's why this is called as uniformly distributed load. Whereas for uniformly varying load, which means the distributed uniformly at varying rate along the length, that's why this is called as uniformly varying load, right? So this is the example of concentrated load. See, this W1 and W2 is concentrated at a single point, then it is called as a concentrated load. Whereas this one is uniformly distributed load. The load is distributed uniformly along the length from point A to point B, right? The rate of distribution is even. That's why this is called as uniformly distributed load, or simply called as UDL, right? So this one is the last category, which is called as uniformly varying load. The load is distributed at varying rate. See here, the W1 per unit length at point A, whereas the end point B, W2 per unit length, right? So end A is different and end B is different. So that's why this is called as uniformly varying load, right? Now we have to discuss in detail how we are going to convert the loads into simply supported beam. So already we discussed about this. This is a concentrated load. So whatever may be the problem, I am talking about the second category, distributed loads. So we have to convert the distributed load into point load, then only we can solve the problem, right? Now, for example, now I am going to draw the uniformly distributed load UDL. How to calculate the UDL, right? So this is the beam and this is the simply supported at A and B. The load is distributed uniformly, right? So we can draw like this, or we can draw like this. This is the beam and this is the simply supported beam A and simply support at point B. And now, so this is also one of the way to represent the uniformly distributed load, right? The load is distributed along the length, right? See, the distance between the supports, which is equal to L. Similarly here, the distance between the supports, which is equal to L. So both are same. The representation of the diagram which is different, right? So we have to convert this UDL into simply supported beam, right? So this is the length and simply support at A and B, right? Then we have to convert this W per unit length, right? So which is the unit of this, which is equal to Newton per meter, right? Now we are going to convert this UDL into concentrated load, right? So for that, the formula which is equal to, the load is distributed along the length, that's why we have to multiply W into L, which is equal to length of the beam, and W which is equal to the load acting on the beam, right? So W into L, and that total load is concentrated at a point which is called as a center point of the length. So that's why, so now we have to draw a concentrated load, because we are going to convert this UDL into point load, right? So the load which is equal to W and which is distributed along the length, that's why we are multiplying W into L, and the point which is acting, which is L by, this is L, and the distance between this, which is L by 2, right? So this side, this is L by 2, right? So this is the way we are going to convert this UDL into point load, right? Suppose, say for example, now I am going to give a small example. This is the beam, and here simply supports are there, right? So from this point to somewhere, the load is acting uniformly. This is called as uniformly distributed load, right? So from this point somewhere, the distance which is equal to this one 4 meter, and this one which is equal to 6 meter, the distance between this which is equal to 2 meter. So this is point A and point B, point C, point D. So 4 points are there. So the total length in between the loads, I mean supports, which is equal to 6 plus 4, 10, 12 meter. Now we are going to convert this into concentrated load. After that we have to calculate, right? So first draw a line, right? So a simply supported beam at simply support at point A. Now we are going to convert this. What is the value of this load, which is equal to 5 kilonewton per meter, right? For this, which is equal to 3 kilonewton per meter. So now we are going to convert this into point load, right? As I said in this case, right? So how much? 5 kilonewton per meter is distributed along the length 6 meter. So 5 into 6, that is our formula, right? Which is equal to 30 kilonewton, right? Clear? 30 kilonewton load, that is concentrated load, and the total length which is equal to 6. So here what is the formula? L by 2 for length. So 6 divided by 2, which is equal to 3 meter, right? So now the load is acting like this, which is equal to 30 kilonewton, and the distance from A, which is equal to how much? L by 2, which is 6 by 2, which is equal to 3 meter, right? So we converted this into point load. Now one more UDL is there from D, right? So what is the value? 3 kilonewton per meter is distributed along the length 4 meter. So 3 into 4, which is equal to 12 kilonewton, right? So 12 kilonewton, this is point B. So 12 kilonewton is acting somewhere, right? This is 12 kilonewton, and what is the length, which is equal to 4 meter. So what is the formula? L by 2, length divided by 2. So 4 divided by 2, which is equal to 2. So from B, 2 meter, from B 2 meter, and mark the point. This point is acting at 12 kilonewton. 12 kilonewton is acting at this point from 2 meter from B, and 30 kilonewton is acting at this point 3 meter from A, right? Clear? So this is how we have to convert the UDL into point load, right? So total, the length which is equal to how much? Here 12 meter, 12 meter. Clear? So similarly we have to convert the varying load, uniformly distributed load, uniformly varying load into point load. That let me explain, right? Now this is the beam, and at end A and end B supports are there. This is called as simply supports, right? And the load is distributed varyingly, right? So clear? So this is how the load is distributed. So here W Newton per meter, which is equal to the length, which is equal to L, right? So this is the triangle, right? So this is the triangle L into B, right? So what is the area for this? Area which is equal to of BH, right? Of BH. So 1 by 2 into B, which is equal to how much? B, which is equal to W, right? B, which is equal to W into H, which is equal to length L, right? So W L divided by 2. This is the way for converting the distributed load, varying distributed load, into point load, right? And what about the point acting at the distance between the ends? We have to find now, right? So that is L from right hand side, from this point 2 by 3 L, or from right hand side 1 by 3 L, right? So total L from left hand side 2 by 3 of L, or from right hand side 1 by 3 of L. So, this is the formula, right. So, now this is converted into simply supported beam. This is point A and this is point B, right. Then the total distance between A and B, which is equal to L, and we are converting this uniformly varying load into point load, which is equal to WL by 2, and point load is acting the point load, the way of representation, which is equal to this for point load, and this is WL divided by 2, right, Newton. And the point, how much distance from A? The point 2 by 3 of L or 1 by 3 of this L. Okay, this is the way we are going to convert. Now, let me explain one simple example. This is the beam and this is the point A and this is point B. It's a simply supported beam, and from this point, so this is the uniformly varying load, and this is the load representation, and the value of this, which is equal to 10 kilonewton per meter, and this is A, and this point which is equal to B, and this point equal to C, and this point which is equal to D, right. So, the distance between AB, which is equal to 2 meter, and BC, which is equal to 6 meter, and CD, which is equal to 3 meter. Now, we are going to convert into point load. So, this is A and this is D, right. So, how to convert this into point load? So, 6 meter is the length for this uniformly varying load, and this is 10 kilonewton per meter. What is the formula? WL by 2, W which is equal to 10 into L which is equal to 6 divided by 2. So, 3 which is equal to 30 kilonewton. This is the magnitude of point load, right. So, and at which point from B we have to calculate, right. So, what is the distance? 6. So, from B how much? 2 by 3 L, or from C 1 by 3 L, right. So, 2 by 3 into what is L? 6. So, which is equal to 4. So, 4 meter from B. So, first take 2 meter, this is 2 meter, and from 2 we have to measure 4 meter, right. So, measure 4 meter, and this is the point where this point load is acting, which is equal to 30 kilonewton, right. So, total distance which is equal to how much? Which is equal to 6, 9, 10, 11 meter, right. So, 4 plus 2 6. So, what is the distance this from D? Which is equal to 5 meter. Or if I want to calculate from C, then what is the value? 1 by 3 L, 1 by 3 into what is the value of L? L which is equal to 6. So, which is equal to 2. So, from C 2 meter from this side, right. So, 2 meter from this side, which means 3 plus 2 which is equal to 5 meter at this point, right. So, if we want to calculate from B point, we can calculate with the help of 2 by 3 into L, or if we want to calculate from C point, we can use this 1 by 3 L, right. So, this is the way we are going to solve the problem. Okay. Thank you.